Okay, so I once again all of you welcome the lecture series of electric power quality. So we are in fifth unit. So fifth unit we are going to discuss the distributed generation and power quality. Okay, what are the different technologies we are going to adapt in distributed generations? You know that what is a distributed generation? So, so whenever a generating station is less than 10 megawatt and these generating stations connected nearby the load locations, remember, nearby the load locations, then only you can call it as a distributed generation, or sometimes some people they may call it as embedded generation, but the correct word is distributed generation. Okay, so how this distributed generating units is nothing but distributed generating units is nothing but, so some diesel motor, diesel generator sets, or some solar plants, or some wind plants, or some tidal plants, whatever different types we are going to assume, but these plants are located near to the load locations or within the load locations. So as I said in the last class, in our college we have some solar plants also there. So that is present in the load location only. So that is also one of the distributed generation unit or plants, whatever it may be. So in our power quality issues or power quality terminology in electric power quality subject, so these distributed generations, how to help to improve the power qualities in the power system. Okay, so now see this, what are the different types of distributed generations will present in the power system. So what are the technologies that we can include this distributed generations to improve the power quality in the power system? So all other things we are going to discuss in this class. Now you can see this class. Okay, what are the different now see this, in the last class we already see the what is the DC, distributed generation. Remember, DC is nothing but a distributed generation. They're small size generators. So it which less than, small size means less than 10 megawatt, 10 megawatt, those are located closer to the load locations. Then that type of distributed generating units you can call it as distributed generations. Yeah. Okay, so that may be of some small idle plants, that may be of gas plants, that may be of some battery storage systems, or some solar plants, some wind energies, all other things, whatever it may be. So less than 10 megawatts as well as close to the load locations, and these distributed generating units you may also, okay, remember, you may also synchronize with the grid. Remember, the grid is operating a very high level of the megawatt or gigawatts level. So in our India, nearly so above 330 gigawatt power is used daily, or generated daily. So in our India, so that type of generating nothing grid, we are going to interface a small amount of this type of DGs. How to interface that heavy powers into this small amount of power? So what technology we are going to use? So before that one, why you are using this DGs particularly? So in early days, is nothing but so in last 10 decades, nothing but up to the 2019 to 2000 century, nothing 2000 year. So this DGs technologies is very rarely we are using. So the fundamental thing for using this DG is to improve the power quality. So to regulate the voltages, to maintain the uninterrupted power supplies, that's why you can maintain the power quality in the power system. But so last 10 years, so this usage is so going to increase. Before that one, they are introduced, but they are not that much used because of the technology as well as the cost. But nowadays technology is helpful to add this much of DGs to the grid also. So the best example for that one is the net metering. Okay, so in our college also using the net net metering technology. So how this in our syllabus, so we are going to see how these DGs will help to improve the power quality. Okay, so which type of DGs will help to improve the power quality? What are the different types of DGs here? So we are going to discuss. Okay, so last class we are already discussed here. So some perspectives on DGs benefits. So we have, so while we are using DG, there is some reason. So in end user practice, so they are used to maintain the some uh, some improve the reliability. To maintain the reliability mean nothing but to maintain the higher efficiencies, to maintain the uninterrupted power supplies in the end user. So nothing but like us, to reduces the power bills, all other things nowadays. So what about the here a distribution person, nothing but transmission and the distribution companies will see that because of using these DGs, we are going to reduces the transmission and the distribution losses, as well as the cost of the transmission lines as well as the distribution lines. So they, that is the perspective, that is the thinking of the distribution and transmission companies on the DGs. So in commercial aspect too also is there. So whenever you are connecting these DGs to the grid, so by using this net metering technology, so some amount of power we are going to inject into the grid. So that power, based on that power calculation, our distribution companies will also pay for us. So in our college is also doing like that. So in the evening time, so college is going to shut down, so entire thing. So on that time, the amount of power that is generated in the solar plant is giving it to the grid. So how much power they can give and calculated based on they can calculate it. So and they can give in some money to the college also. So at the same time, in the morning time, you are going to utilize some power from the grid also. So they can, it can subtract that one, how much power we are utilizing the grid, how much power we are injecting the grid. So they can subtract that one, then remaining amount they can we are going to pay the distribution companies. So the net metering technology is like this. So in commercial aspect too also it is very much helpful. So what is the main drawback of these DGs? What is the main drawback of these DGs? So the main drawback is the installation cost, the primary installation cost, the economical way. So it is somewhat higher cost. So it is somewhat higher cost. So whenever you are connected this DGs in the some end user equipments and other things, you just think that, so what is the maintenance cost? So who can maintain the DGs? Nothing but distributed generation. But suppose you have the solar plants in our college like that. So we have some plants and all other things. Who can maintain that one? So what is the maintenance cost? How to maintain that solar plants? All other like that. So I'm giving the one example only, then real time example. So how to operate if there is some problems occurred in the system? It's like some frequency failures or some interconnection problem is there. Then who can solve that problem? So many operating issues are present in the system. So at the same time, how this DGs will help to improve the power quality. These are the some things we are going to think while you introduce these DGs in the power system, or include these DGs in the power system. There are some perspectives. So last class we are already discussed all other things. So what are the some perspectives? Is nothing but what are the some thinking of that one. So where you can place these DGs. Now see this within the load locations, or for the same feeder we are going to connect these DGs. So okay, so now see this today's class we are see this what are the DG technologies. Okay, so DG technologies in the sense, what are the different types of DGs here we are going to discuss. So in the textbook they can give in the DG technology that name, but the suitable name is what are the different types of DG sets, distributed generation types. That is the correct name. So, but we are not discuss the technologies in the sense here. Some solar also we have hundreds of technologies are there to improve the efficiency of the solar, nothing but solar plates, PV cells. What are so many technologies are there here? This means here we are going to discuss different types of DGs, distributed generations. The first type is reciprocating engine generator sets. So nowadays we are going to see in commercial areas, nothing but some shopping malls and other things. We are going to see this and apartments also. So we are seeing this generator and engine and diesel engines and generator sets. So that is also the one DC to maintain uninterrupted power supply. When there is a power cut happen in the system, so happen in that distribution line, so on that time so that commercial purpose buildings or so whatever it may be, so they can on the DGs, nothing but diesel generator set to maintain the uninterrupted power supply. Then second category is combustion gas turbines. You know that in our Andhra Pradesh we have the some combustion gas turbine plants nearly Simhachalam, some near to the Vizag. So we have some gas plants is also there. So by using these gas plants, we are going to give or supply some amount of power to the grid. So then fuel cells is nothing but batteries. So batteries to maintain uninterrupted power supply in our laboratories. So we are also going to use this in our college also. We are using these fuel cells to maintain the uninterrupted power supplies. Then next most important categories nowadays widely using these two wind turbines as well as the photovoltaic systems is nothing but a solar cells. So nowadays these two is using very well. So there are some advantages as well as some disadvantages of this one. You observe one thing, this all the things here, all the types, nothing but 5 types. So these are not the base loads, are nothing but base plants. These are not the base plants. We are not treating this as a base plants. In our India, the base plants you can treat it as a some coal plants. So now that we are also moving to the base plants and some this energy also, some nuclear energy also, we are treated as a base plants. So not this diesel generator sets and gas turbines, fuel cells, wind energy as well as photovoltaic energy. We are not treated it as a base loads or nothing but base plants. That means they are not continuously supply the power to the loads. Okay, these are the very small plants. So these plants are not continuously supply the power to the loads. So there is some specific time whenever there is some drawback or there is some power failures or there is some power quality issues in the power system, then only you can use these DGs. But nowadays, remember, these two wind and photovoltaic systems we are very much used in our India. So in our Andhra Pradesh also we have different types of wind and photovoltaic systems. So in the last month, I think so one plant, nothing but a, uh, a floating solar plants. So it is nearby the Vizag. So located in the Mudsalloa so area. So that solar plates that are placed on the above the water, nothing but water. So that we can call it as a floating solar plant. So that is also installed in our India. So that is telecast by the National Geographic Channel also. So that is one of the technology. So nowadays because of improving these technologies, so very frequently we are using this wind and as well as photovoltaic systems. So what are the drawback of these systems? So for suppose you are considering the wind. So in wind waves, so nighttime wind waves are very higher. So nighttime wind, so this generates the more power when compared to the morning time. So what is the drawback of these photovoltaic systems? So what is drawback here? So in the night time, it is not going to generate the power. Nothing but so this photovoltaic systems as such, they require the some energy, nothing but the sun energy, sun rays. It requires sun rays. So morning time it will generate the some amount of the power. So night time they will not generate the some power. So these are the some drawbacks. At the same time, the installation cost is also very. You know that in the 2000 2010 on that time 2000, so per unit cost of this solar as well as wind, they can charge up to the 16 to 20 rupees also. Now that is reduced to the 2.4 2.3 2.5 nowadays per unit cost. So because of the improving the efficiency of the systems as well as the improving the production, so as well as the cost of this solar as well as wind as well as reduces, nothing but plates and equipment cost is reduces. So that's why these are the cost of per unit generation is reduced today. So the one more main drawback of this solar systems and all other things will require the large amount of the space. Okay, so that space cost is somewhat more at the same time. So the cost per kilowatt is nearly 1 lakh in India nowadays. Whenever you want to generate 1 kilowatt of the power by using these photovoltaic systems, it will require nearly 1 lakh to the installation cost and all other things. So there are some drawbacks, but these technologies, nothing but wind, solar, tidal, and all other things, we can also call it as a clean energies. Nothing but there is no harmful effect in the system. So nothing but it is not generated with some carbon dioxide, some sulfur dioxide, or other gases like that. So a clean energies and as well as at the same time renewable energies. Okay. So now see this reciprocating generator sets. You know that very well. All other things you know that. So this see this a generator and a is nothing but a diesel engine. It's simply a diesel. Now see this a diesel reciprocating generator set in the sense here. So a diesel engine is connected to the generator. So a best example for you can see this in the shopping complexes. So many apartments, so many shops, commercial areas. In our college also we can use this diesel generator sets. Okay, so what is the main advantages of this one? So whenever wherever the load requirement is there, on that place we are going to add this diesel, nothing but a diesel generator set. Add this diesel generator set. So here, so whenever you want to run this diesel engine, you require this some amount of the fuel. You can call it as a diesel or petrol, whatever it might be, diesel. So the cost of the diesel also increasing nowadays. So, but because of using this diesel as a fuel, so it will emit these some harmful gases also. So it may pollute the environment. Okay, so why this reciprocating type of engines we can use here to maintain the uninterrupted power supplies in the loads. So remember, to maintain the uninterrupted power supplies in the loads, but you may remember one thing, this DGs will not allow to addition of the loads. Okay, you cannot add the loads. Okay, nothing but improving the loads. For example, this DGs we are going to use for 10 kilowatt load. So that load only it can withstand. So for suppose you can add this some another 5 kilowatt, nothing but 15 kilowatt. So this DG technologies, these DG types will not allow that one, because these are the fixed. Okay, fixed rating is there for these DGs. So now see this this may be of this diesel generating sets. This may be of three-phase systems nowadays in our India. We can use it as a 415 volts for that system. Okay, so what is the main drawback of this system? So it can produces the this or it can emit the these gases. Okay, so at the same time the efficiency is also less. Now see this, the efficiencies is in the range in between the 35 to 40% in this reciprocating pumps or reciprocating engines. So now see this second category is nothing but a combustion gas turbines or gas plants. You can also treat it as a gas plants, but that range is nearly of a 10 megawatt up to the 1 to the 10 megawatt. Then only you can call it as a DC, distributed generation plants. Otherwise, you can call it as a some base load plants and other things. Okay, so this DC. So whenever you require some power, so that time. So for suppose we can consider one area is nothing but in our Eluru. Some there is some frequent power cuts is there. Due to some addition of the some loads is there suddenly. So on the time there is available in the DC, DGs nearby the load location, so you can on that one. You can maintain the some loads. You can maintain the constant power supply to that loads and all other things. So some way these gas plants, gas turbine plants, you can also call it as a somewhat clean energy, above 95% clean energy. Now see this clean energy because it has the gas, because it has the gas. By using that gas we are going to heat the turbine, same process like the coal plants. Instead of coal as a fuel, we are using gas as a fuel. Okay, now see this. So in this, what type of generator we are using here? We are using a permanent magnet rotor type generator. We are going to use here. So this is the one. See this diagram. See this figure. So this is the micro turbine in a combined heat and power installation. So this is very old technology. So but in our syllabus it is there. So that's why we are going to discuss here. So this is very old technology. You can see this. This is the heat extraction. So now see this. This is a micro turbines, means a small generating turbine. So now see this. It will produces as a size of 30 to the 75 kilowatt mostly. So, so what is the efficiency of this gas turbines? So this efficiency is nothing but 35% to the 25%. Not the 30 to the 25 to the 30% efficiency is there. This technology. So where you can use this technology? This technology is best suited for combined heat power applications in a small and medium sized commercial industrial facilities. Industrial. So industries, nothing but we have the for suppose we have the some coal sorry we have the some plants like some paper mill is nearby there. So in Rajahmundry we have some two paper mills is there, some Andhra paper mill, so as well as some IP international papers is there, some different types of paper mill and sugar mills, Andhra sugars is there. So on that time, if there is a availability of the gas, so nearby that load location, so we are going to use this for to maintain the continuous power supply. So commercial purpose we are using this gas, because why it is using commercial purpose means here the cost is the installation cost of this plant is very more, so when compared to the diesel reciprocating engine generator sets. So that's why. So most vividly this combustion gas turbines most people use it for commercial and as well as the industrial purpose. Okay, now see this. What are the gases now? So from the biomass gas. So what are the fuel? So what are the gas types here? So biomass gas, some flare gas, natural gas. So we are going to utilize or we are going to use it as a fuel for generating the power. Then another one is the fuel cells. Is nothing but a batteries. Fuel cells is nothing but a battery. So batteries. So fuel cells is nothing but a batteries. We are going to use here some batteries. So battery bank. So this is very old technology to maintain the uninterrupted power. So whenever there is a frequent power losses or power interruptions in So now this fuel technology, this fuel gas, this fuel cells is nothing but some batteries, a battery bank. Now observe this diagram. So this is the one battery bank. Now this is one battery bank is used to maintain the uninterrupted power supply most of the cases. So in our college, colleges, small industries, even though a distribution or what substations also we are going to use these batteries. Our houses, in our houses, the best example for this one is in our houses. Also, we are going to use these batteries to maintain the uninterrupted power supplies. But uh, what is the one thing here? So whenever you want to fix the rating of the load, so that rating only we are going to give it to these batteries. So once the load rating is increases, is nothing but the amount of load we are going to add this fuel cells is increases. So this fuel cells is not able to given that power. Okay, because of this the rating of the fuel cells and all other things, the loads that is added to the fuel cells is already defined. So according to that one, you can add this capacitor banks or nothing but battery banks. So but the main one of the main drawback of this fuel cells is the cost. So the cost is also very much higher, but the heavier loads we are not going to add these fuel cells because the load size is increases. Okay, the number of batteries we are using is also increases. So but nowadays technology, nowadays you know that everything is going to change very rapidly. Nowadays fuel cells is batteries is very much essential for any device. For suppose we are using the cell phones, so and battery is also there. So nowadays so in the introduction of the cell phones and other things 2000 century on the time. So you know that the capacity of the fuel cell is nothing but the so 500 mAh, 400 mAh. Okay, so that is there. But nowadays in recently some companies are also introducing some 8000 mAh also, some 5000 mAh, 8000 mAh also. Okay, so that because of the technology is increasing, so the cost is also reduced. So nowadays the cars is nothing but cars also so using these batteries. So cars is nothing but in Tesla. So the first cars they introduced this Tesla, very famous cars, Tesla. So in our India also some companies like Tata Motors and all other things, they are already introduced these EVs, so electric vehicles also. So these electric vehicles is the fuel for this electric vehicle is the batteries. So battery, chemical energy is nothing but batteries. Okay. So nowadays, because of this technology improvement, the introduction of these fuels is very rapidly changes. So that's why the somewhat the cost is also changes. So in our houses also, most of the houses we are using this batteries to maintain the uninterrupted power supplies. Okay, so the next one is the most important one is so in our India is more about focusing this renewable energy. So for one of the renewable energy is the photovoltaic cells, a photovoltaic system. You can now see this diagram also. So these are the some solar cells that is installed on the rooftop of the building. So like our college, so in our college also we are installed the solar plates on the rooftop of the buildings, so we can utilize the space. So some newer technologies is there. So so not only this we are using this solar cells in commercial purpose. This photovoltaic systems or solar cells is also used for the in the houses also, in the households also, is like in some apartments and some houses. Nowadays in most preferably these are using in uh, it's like some farmers also are using for for borewells, and all other things. So there are some advantages of this photovoltaic systems. More advantages is there. So where you can install this photovoltaic system. So you can install these photovoltaic systems on rooftops or flatted areas. So it's nothing but in our apartments or rooftop of the buildings, rooftop of the apartments or rooftop of the commercial buildings, or in our flat areas. So whenever the land is not utilized for the any another purpose, that type of the land we are going to install this photovoltaic cells, are some most advanced technology nowadays. These solar plants are also going to utilize or install on the water surface also. So the best example for that one is you can also search in the internet. So in Vizag area, you have to identify this water based solar plants. So on the surface of the water, they are installed this solar plates. You know that installing like that, the initial investment is very high, but the efficiency of the solar plates is increasing. So the power generation for the solar plants is increasing. So there are some reasons behind that one. So in our India right now, uh, so for you are installing 1 kilowatt of this solar plants in our household or all other things. So it requires nearly 1 lakh rupees money. So in our residential units, the range, nothing but the size of the solar plants in between the 2 to 6 kilowatt. Okay, so once installed, so before the installation, the installing cost is very high. So, but once installed here, the incremental cost of electricity is very low because of using the net metering technology. Because of using the net metering technology. What is this net metering technology? It is very simple. So how much power you are going to generate by using the solar cells and giving it to the grid. At the same time, how much power you are going to use from the grid. So you can so the net meter, it can calculate it, how much power you are going to give in the grid, how much power you are going to utilize the grid from the grid. So the difference it can calculate it by using this net meter. So that amount only, the difference units only, that power only we are going to pay them. So that's way it will drastically reduces the unit, nothing but the power charges in our houses or commercial buildings. So like our college also drastically the power bill is drastically reduces. But the primary thing is the installation cost is somewhat higher. So then another thing is you have to take the some responsibilities to maintain the solar panels. Nothing but there are some dust particles on the solar plates. So installed on the solar plates, nothing but, so placed on the solar plates. So you can clean that solar plates. So some maintenance cost is there. But the life of the solar cells is nearly up to the 25 to 30 years. Okay, so 10 to 15 years we will get the installation cost and all other things. So remaining 10 to 15 years we will get this some profits from this solar plants also. So this is very clean energy, very clean. So there is no such type of nothing but emission of the gases, and there is no it is not harmful for the environment. So it just utilize the solar, nothing but the sun energy to generate the power. So I'm not going to how that much deeper in this one. So because in our syllabus we have to just see what are different types of the distributed generation systems. Okay, so now see this all the things. So whatever it may be, diesel generated sets and all other things, reciprocating, it can generate the AC. Okay, now see this combustion turbines also, it can generate this, but this fuel cells, it has stored the energy in DC by using some inverters, can convert some DC into the AC. Likewise photovoltaics also, it can generate the DC. So by using some another system, nothing but some inverters, some converters, So we are connecting some DC generated power into the AC, then giving it to the grid. Okay. Similarly, there is one another thing is also there. So these solar energies, solar plates will generate the energy in the morning time. So night time there is no sun energy is there, and that time it will not going to generate the power. So then next category of the DC technology is the wind turbine technology, wind energy. You can simply call it as wind energy. So where you can use this wind energy. So this wind energy is in our Andhra. So mainly placed on the Anantapur on that areas. Nothing but on that area. So the wind energy, the wind is very high somewhat. So so before you install this wind, so you have to check whether which place the wind energy is more, the wind is more. So on that area only you can place this one, but solar we can place anywhere. So in our India, so best place for so one of the best places for installing the solar plates, because the temperatures in our India, for any season it is more than most of the states. For any season, the temperature is more than 25 degrees. So 25 degrees is very much sufficient to generate the power by using the solar plant, solar cells. But now see this wind type of the wind turbines. So we are not place these wind turbines everywhere. We have to check where that wind is very more. So on that place only you can place this wind turbines. So there are different types of wind turbines is there. So and so you know that wind is very much available in the night time. So so these wind turbines or wind plants will generate more power on the night time, so when compared to the morning time. So morning time also this wind energy is generated, but very little bit. But night time this generates very more. So this is also the clean energy. This is also very clean energy. So it uses a wind as the fuel to generate the power. There are some different types of generators we are going to use here. Okay, some auxiliary generators and some induction type of generators, different types of the generators we are using here. So this is one of the very clean energy. So now see these different types of generators there here. So convention squirrel gauge induction machines are wound rotor induction machines we are using here for this one, this place. It's nothing but to generate the power. So at the another type is double fed wound rotor induction machines. So also we are used to generate the power. So simply it is very simple. So whenever there is a wind flows on that one, so that wings, so it simply rotates based on the number of rotations. So that shaft is connected by the this type of the generators, nothing but induction machines and all other things. So it is rotating based on the number of rotations, the amount of power is generated. So very much easy. So we have to remember all other things that, but these five technologies. So in our syllabus only we have the five technologies. We have the other technologies also there. Tidal energy. We have another type of the most of the countries. We are going to introduce this tidal energy. So it's nothing but based on this nothing but sea tides, sea waves. So this tidal energy is generated using the seas. So based on these sea waves, so some amount of by you can place the some generators on that waves. So that waves are moving continuously. So based on that waves, so the amount of power is generated. So you can see in some videos and all other things in our internet also. So these are the some technologies introduced in the DGs, nothing but distributed generation, to improve the power quality. Now see this, the main thing is how these technologies will helpful to improve the power quality. This is our concern, because we are dealing the entire things to how to improve the power quality. how the power quality problems will injected into the system, how that problems will present in the system. So how to reduce that problems. So one of the method is to by using this DGs to reduces the power quality problems in the power system. So now we are already seeing these technologies. Now the question is where you can place this, or where you can connected this, or how to connect these different types is nothing but solar, photovoltaic, and fuel cells. Then how to interface this uh, DGs to the system. So how to interface this one? So how to interface this DGs to the system? So what is the primary concern while interfacing this DGs to the utility systems or grid? How to interface this DGs to the grid? Nowadays, the main something they are called it as a microgrids. Microgrids also like this. Microgrids. These are the microgrids. Microgrids is nothing but a small grid. So we are going to add the DGs to that system. Okay, so there are so much type of are very best microgrid technologies are there nowadays. So now see this how to interface this one. So how to interface this to the system. So the primary concern here is that what is the impact on the DC while you are going to introduce in the distribution system. You know that these are very much these are interconnected, these are interfaced in the distribution systems, because the rating of the DGs is very less. So that's why we are introduced are very near to the load locations. So that's why we are interfacing these DGs to the distribution system most of the cases. So here the question is, so what is the impact of these DGs while you interface in the distribution systems? So now see this, while this energy conversion technologies is nothing but DGs. So this plays which role? So how to reduces the power quality issues in the power system? Most of the power quality issues related to the electrical system interface. You know that. So there are some drawback by using this DGs also. You know that for suppose some fuel cells, for suppose. So that is the battery. That is some capacitors. There is on and off. There's some transients are there in the system. So there are some drawback is also there, but there are some advantages at the same time. Okay, so there are some notable here, remember these points are very careful. There are some notable exemptions included in this one. Now see this first point: the power variation from renewable sources such as wind and solar causes high voltage fluctuations. Why high voltage fluctuations is nothing but, so these are not constantly given, are not constantly injecting some power into the grid. Nothing but based on how this wind and solar will work, based on the climatic conditions, based on the nature. You know that wind is nighttime wind is very more in solar, so morning time is very more for due to the some rainy season. There are some because of some cloudy weather, so the amount of the solar energy produces reduces because of the cloudy weather and all other things. That depends on the climatical conditions. So based on the climatical conditions, these plants, nothing but solar and wind plants, will not generate or will not give a constant amount of power to the systems. There are some fluctuations in that. That is the first one. Then second one, while using fuel cells and micro turbines. Fuel cells, you know that batteries and micro turbines, that what gas type of the turbines, do not follow or do not step is nothing but step changes is nothing but you do not add the load to this one. For suppose these plants are fuel cells, and these plants are designed to withstand the 10 megawatt of the load. 10 for suppose 10 kilo or 50 kilowatt of the load, you can design these fuel cells as well as micro. So that load only it can withstand. For suppose there is some addition of the load is there. So this type of the two devices is nothing but fuel cells and micro turbines will not to uh, withstand that addition of that load. Okay, so there is a some fixed load we are going to hear. So at the same time, some misfiring in the reciprocating engines is nothing but diesel and generator sets. Some misfiring because of the rotation. So it can produces some type of flickers, particularly in magnified the response of the power system. So due to because of this problem, nothing but a misfiring of reciprocating engines and all other things. So it will cause some flickers in the system. These are the some drawbacks. So these are the small drawbacks while we are using this DGs, distributed generators. So to interface in the systems, but you see this drawback when compared to this drawback, there are more advantages. So that's why this, we are going to introduce again this DGs into the system. So there are some main electrical interference. Some is nothing but different types of DGs are nothing but the what type of missions we are going to use these DGs. So nothing but the synchronous missions, asynchronous missions, then electrical power inverters. So these are the some main electrical system interference. So now see the synchronous missions. So nowadays at present we are going to use these missions. So by using as a base plants, synchronous generators. So then we have another types asynchronous machines. Are nothing but most of the cases we are using this type of machines to generate the power in wind turbines. So now see this electric power inverters, some fuel cells technology as well as solar type. We are utilizing this. Nothing but they are generating power in DC, but we want the AC. So by using this inverters, we are converting this DC into the nothing but DC into the AC. Okay, so next class we are going to discuss these three things. Okay, how this synchronous machines, how this asynchronous machines, how this power electronic inverters, inverters, how to interface these three type of inverters in along with the DGs. So all other things we are going to discuss in the next class. Okay, thank you for joining today's class. Thank you very much.